So now we're going to get on to the second very important equation in collisions, and that's Newton's law of restitution, which is sometimes just called the bounciness equation. So we know that the conservation of linear momentum is a common law which is abided universally. So by this, if we drop an object onto the ground, it should theoretically rise to the same position as it was because the Earth isn't moving. If you try this, you'll see it isn't the case, not for even different balls, but for even different surfaces. So if you dropped, say, a volleyball onto concrete, so volleyball is a very bouncy kind of ball, versus if you dropped, say, a stone. So the volleyball will bounce higher than the stone if it's hit on the ground. But what if this was made of carpet? So the volleyball on the carpeted floor wouldn't bounce as high as it would on the concrete floor, and neither would the stone on the carpeted floor. So it depends on the material of the object falling onto the surface and the surface itself. So in order to calculate this, we find the bounciness of the surface, the ratio of which is called the coefficient of restitution, which is this E here, which is minus V over U in vector form. Essentially, it says here anyway, but with a collision, you always change, or the velocity changes directions. So as soon as an object hits the ground here, it'll have a velocity straight down. But then, of course, after the collision, it'll have a velocity straight up. These are, of course, in opposite directions, so adding the minus sign allows us to have E within the range that we need, which is between 0 and 1 inclusive. So when E is 0, we get what's known as an inelastic collision. So if we have a ball rolling to a wall and the collision is perfectly inelastic, it will essentially just stick to the wall. When E is 1, we get a perfect elastic collision. So this time when it hits the wall, at say an initial speed u, after it hits the wall, it will rebound with the exact same speed. This can be shown rather easily. We know that when E is 1, we get an elastic collision, so 1 is minus V over U, which implies that the initial velocity is minus the final velocity. And the same thing here, if we get 0 is minus V over U multiplied by U, we'd simply get that V is 0, which fits the definition of an inelastic collision.